Okay, so yesterday we talked about, what, rabbits and water hyacinths, right? Because, you know, I try so hard to get, like, real, true stories that we can do exponential growth problems about, or any other problems about, right? So I chose another true story today. In the next 10,000 years, the star which Earthlings have called WOH-G64 will explode as a supernova. The planet was inhabited by creatures who were very similar to those in the book called Flatland. Has anyone in here read the book called Flatland? Have you ever read the book called Flat Stanley? Right, so the bulletin board fell over. Now the only difference here is in this situation, all the creatures are rectangles, right? In our true story, okay? All the creatures are rectangles. To locate a planet capable of sustaining life for their people, a spaceship from a planet orbiting WOH-G64 traveled 160,000 light years to reach our solar system. One alien was left behind on each of our solar system's 9 planets and one of our dwarf planets, Ceres. Because we all know Pluto's a planet. The alien who was left behind on Earth noticed regular shaped objects mounted on poles along the roads. One stated, free concert in the park on Saturday. Another stated, garage sale. What is the alien singing? Signs, right? We sing signs, okay? In order to be inconspicuous, she took on the shape of a similar rectangle, 18 units wide by 24 units long. At first, this planet seemed perfect, but exposure to Earth's atmosphere caused something very strange to happen. After exactly 1 hour, the alien split in half. Now there's 2 aliens, each half as big as the original alien. After another hour, each of those 2 aliens split in half. Now there are 4 smaller aliens. After each hour, each alien split in half again. You see how disturbing this true story is to me? Okay. So we're about to model what happened, right? To the number of aliens and the size of each alien by repeatedly cutting each alien in half. Okay, so now to be technical, we're not cutting an actual alien. Okay? We're just going to cut a piece of paper. We're going to pretend this is an alien. Okay? This is an alien. So here's my alien. So after 1 hour, what happens? In half? Okay. Now I know some of you are quite disturbed that I did not measure, that I just cut. Are you going to be okay? Okay. So now I have 2 aliens. So after 1 hour, I had 2 aliens. Everybody okay so far? Okay. Okay, so I have my 2 aliens. I'm going to take this paper off for today so you can see the aliens a little bit better. Here's my aliens. Okay. Then, another hour passed, and what happened? How many aliens do I have? 4, okay. 4 aliens. So I got my 4, okay. And then another hour passed. Other way. How many aliens do I have? 8 aliens? Oh my goodness. And then another hour. Imagine if this was a real alien. I think it would be screaming. Should I have said that out loud? Sorry. Can you see all the aliens? Okay, how many is there? 16. Do I need to keep cutting? No, why? You can see the pattern, can't you? Okay, so after 5 hours, how many aliens are there? 32. And after 6 hours, how many aliens are there? 64. Now, can you tell that this square is shaded a little bit? Like, there shouldn't be anything in that square. It should be shaded. And so should this one. Okay? Okay, excuse me, aliens. Excuse me. And we've had quite the experience lately writing stuff in exponential form, right? Number of aliens in exponential form. In the last couple days, we've talked about like how our base comes to be, right? How does our base come to be? What does the base mean in our exponential equation? It's how things change, right? What is it called? The common what? Ratio. Yeah, ratio. Okay, common ratio. So what's the common ratio in this table? If we're finding common ratio, remember we take a number and divide it by the one before it? So what's 8 divided by 4? 4 divided by 2? 2 divided by 1? So would you agree that my B in this problem is 2? Well, what's my A in this problem? Yeah, because what does A stand for? What I started with, right? And how many aliens did I start with? 1. Do I need to write 1 times 2 to something, some power? Why don't I have to write that? Anything times 1 is itself, right? So I don't need to write it. So which one of these is the easiest to see? Probably this one, right? 2 to the first power? Isn't 2 to the first power 2? Because we're talking about number of aliens and the number of aliens in exponential form. Yeah? Well, what's this one? 2 to the 0. Why is it 2 to the 0? Because that's 1, right? Okay. So what about this one? 2 squared, right? What about this one? 2 to the 3rd. What about this one? 4th. Hopefully you see the pattern, yes? And then, so 2 to the 5th and 2 to the 6th. So what's this one? If I have n aliens, based on the time landing, where is the time landing in the exponential form? It's the exponent, right? So if this is the time landing, then what's my exponential form? 2 to the n. Okay? The area of each alien. Well, what was the area of the first alien? I'll remind you. Here was my first alien. Not exactly my first alien because I didn't put it back together. This is just a new piece of paper. Okay, what's the area of this alien? What's that? 18 by 24. So this is 18 and this is 24, right? Okay, so how did they get 432? Oh, so they said 18 times 24, right? And then we cut the alien in half this way. So this isn't 24 anymore, is it? What is it? It's 12, isn't it? So this should be 18 times 12. Well, what is 18 times 12? Yeah, if you don't know off the top of your head, what could you do? Yeah, calculators are good. 216? Okay. And then after another hour, this one got cut in half, right? So this is not 18 anymore. What is it? 9. So this alien is 9 times 12. What is 9 times 12? 108. Okay. And then the alien got cut in half. So the top used to be 12. What's the top now? 6, because it's half of what it was before, right? So this is 6 now. So this should be 6 times 9. And what's 6 times 9? 4. And then alien got cut in half. So that's not 9 anymore, right? What is it? Even aliens can have fractions and decimals? Oh, geez. What is 6 times 4.5? If I had to guess, it was 27. Right? 6 times 4.5. Now, where do you think I came up with that number? Wait, what? Like, I didn't do the math there, right? I didn't multiply these two numbers. I just saw that this was half, and this was half, and this was half. So shouldn't this also be half? Yeah? So what should this one be? I don't want to cut any more aliens, right? So what should this one be? Should be 3 times 4.5. So it should be what? 13.5? And if you check this, it is, isn't it? And then one more time. 3 times 2.25? 6.75. Any questions? We got our table complete, yes? Okay, let's go to the next page. Now, do you see this part up here that's in italics? We're talking about the number of aliens as a function of time. The number of aliens as a function of time. So if I'm looking at my table, what 2 columns am I talking about? Number of aliens versus, or as a function of time. Aren't I talking about these first 2? So yay, I'm glad I have the rest of the table, but for the first couple questions, I'm not even paying attention to this part, am I? Okay. So, after how many hours will the alien population be 512? Oh, great. I don't have 512 on my table. But I have an equation, right? So I could guess. I could plug in numbers for n until I got 512. Or I could plug in 2 to the n on my calculator on a graph and look at the table, right? To find 512. Which way did you do it? So first of all, what's the answer? 9. 9 what? Hours. And then how did you do it? I gave you 2 options. Did you do another way? Okay, whichever way you did, I need you to write it down. I plugged numbers in until I got to 512. I plugged numbers in for n in 2 raised to the n power until I got 512. I entered 2 to the n in my calculator and looked at the table and found 512. Either of those options are fine, but I need you to write it in a sentence. Does that make sense? I'm not going to write anything because I don't know how you did it, and I don't want you to just copy mine. Does that make sense? You're allowed to have your own thoughts. How large would the alien population be after 12 hours? And where did that come from? Oh, okay, so you said 2 to the 12th power? And you said that was 4,096? 4,096 what? Aliens? Now it says, explain how you determined your answers. Didn't I just? By putting my work right here, didn't I just explain how I determined my answer? Yeah? So does this one need a sentence? No. Okay. What about after 24 hours? Can we do it the same way? So 2 to the 24th power. Whoops. 24th power. And what is 2 to the 24th power? 16,777,000. What'd you say? 216. Excellent. 16,770,216 what? Aliens. Is the alien population growing at a constant rate? So I see 3 people shaking their heads, and I see 3 people nodding their heads. First of all, we understand the difference, right? Okay. Shaking our head or saying no, nodding our head, we're saying yes. So we are unclear, right? If it's growing at a constant rate, what is happening to the table as I go down the table? Isn't it adding the same thing every time? Is this table adding the same thing every time? So is this growing at a constant rate? No. No, but what? But, so we're still waiting a little bit on that, if that's okay. So can we say it a little bit less mathy? It's not growing by a constant rate, but what's happening to each number in the table? Each y value in the table is what? What'd you say? Being multiplied by 2. Yes? Okay. So on the grid, plot the number of aliens with respect to time. So remember, we're only using the first 2 columns. So at 0 time, there was 1 alien. At 1 hour, there were 2 aliens. At 2 hours, there were 4 aliens. Now, is this exactly 1 and exactly 2 and exactly 4? No, because it's counting by tens. I'm getting close, right? Which is what I asked you to do, right? Okay. 3 is 8. 4 is 16. 5 is 32. And 6 is 64. Whoa. Whoa. Should the points on the graph be connected by a smooth curve? If not, why not? And then provide at least one reason to explain your answer. If I connect the points, what does that mean about every point on the line that I create or the curve that I create? It's also true, right? So if I draw a curve or a line, however you want to say it, right here, then after 1.5 hours, I should have like 3 aliens. Why not, Brendan? Why are you shaking your head at me?
Because they multiply every hour.
They
Divide.
only split on the hour. That's exactly right. So should the points be connected with a smooth curve? No. No, thank you. And why not? The aliens only split, oops, not slit, S-P-L, split once an hour. Is that how you want to say it? Once an hour. Everybody okay so far? Okay. Now, what do you notice above question number 6? Area of each alien as a function of time. The area of each alien as a function of time. So this time we're ignoring the 2 middle columns and we're just looking at the first and the last. Everybody okay with that? Okay. So we need to plot the graph. All right, let's see. After 0 hours, the alien was 432. 0 hours, 432-ish. After 1 hour, it was 216. After 2 hours, it was 108. After 3 hours, it was 54. 4 hours was 27. 5 hours was 13.5. 6 hours was 6.75. Okay, so far? Describe what's happening to the size of an individual alien. It's getting smaller, it's decreasing. Those are all great words. Can you be a little bit more specific? It's getting smaller by what? By half, right? Okay. Each alien is getting smaller by half. That's a weird looking H. Is that better? Okay. Should I connect this one? Why? Same reason, right? Same reason as before. Okay. The graph of the alien's size with respect to time is an example of exponential decay. Would you agree with that? What's this? Growth, exponential growth, okay. This one's exponential decay. Based on the table and the second graph here, create a definition for exponential decay. We've already talked about it. Can you put it into words for me? The Y value. That's a good start. We don't want to use a word to define a word. No, that's okay. That's a good try. What's happening to the Y value? Decreasing, right? By this time half, right? Is it always half? So what could we say? By a common factor? Would that be okay to say? By a common factor. Is that good? Do we need to add anything else? Or is that a good definition? Yeah. If you open a math textbook, is that what it's going to say for the definition? No, I didn't ask for a math book textbook definition. I asked for your definition, right? This is a perfectly fine definition. It's not all the mathy words, but it makes sense to us, doesn't it? Okay? Will the aliens disappear? I want you to circle that one. Just circle it. Why do we usually circle things? Important, right? So will the aliens disappear? You see the problem? Could you justify an answer of no? You could, right? Could you justify an answer of yes? Uh-huh. Somebody say the aliens will never disappear. Someone raise their hand and tell me the aliens will never disappear. Can you tell me why? Because they're always splitting in half, right? They're always splitting in half. There's always going to be aliens because they're always splitting in half. Okay? Does that make sense to you? That's a logical thought process, right? Now, will the aliens disappear? Yes. Somebody raise their hand and tell me, yes, the aliens will disappear. What you got?
Yes, they will. Because
Why?
you can't see them anymore.
You can't see them. You know they're still there because they're dividing in half, but the aliens are eventually going to be so small that you can't see them. So this is like a tricky word, right? Will they disappear? Are you talking about from sight or from existence, right? So my question to you is, first of all, I'm not going to write an answer. You're going to write an answer just like we did a minute ago. I want you to choose one of those answers, yes or no. And I want you to justify it. It doesn't even have to be the justification that we just talked about together. It could be another justification. All right, you got an answer? Now, I'm just curious. How many of you chose yes? Raise your hand if you chose yes. And how many of you chose no? Interesting. Okay. All right. Number 10. What's the sum of all the areas of all the aliens at any point in time? 432.
Square units.
Oh, okay. Let's go ahead and write that. Square units. Why? They're not splitting in half and growing to the like original size, right? They're just completely splitting in half and splitting in half and splitting in half and splitting in half, right? So if this was our alien, again, this alien did not get put together. It's just another piece of paper, and it's not an actual alien, right? Here's my first alien. I just cut it in half. It's still, these two are their size, but they didn't get any bigger, so they're this size. And then when I cut it in half, there's 4, and you see what I'm trying to show you, yes? Okay. And I also want you to circle number 11. Okay. Will the aliens be able to take over planet Earth? And then I want you to write a paragraph. Tell me about a paragraph. How many sentences? At least 3, right? What else do you have to make sure to do in a paragraph? Punctuation, capitalization. Now, you're all looking at me like I'm some sort of weirdo. I'm used to that, but I'm saying, I know this is not English class, right? But don't you have to know how to read and write even in math class? Yeah. Okay? So I want you to spend the rest of the time Will the aliens be able to take over the earth? I don't want you to talk about this with anybody. I want it to be your answer. Just your answer. Okay? Justify why you think, either yes or no, the aliens will be able to take over the planet. So your first sentence should be whether you're saying yes or no, right? And then the at least 2 other sentences in the paragraph should be an explanation of why you're choosing yes or no. Any questions?